Welcome everyone. Let us go through the basic concepts of Pig again. So what is Pig? So Pig is a platform that makes big data analytics easier on unstructured data. So there are two important points here. One is that Pig is a big data technology, and then Pig works on unstructured data. So let's see how and why Pig solves these two problems. First, what's the problem with big data computing? What you can see here is MapReduce. This is a classic code, native Java code of counting a few lines in a file, in an arbitrarily large file. And as you can see, you can do this with not less than 59 lines. So that's just too much. So this is one reason Pig got created, because you can do the same thing. So just counting how many lines you have in Pig in 4 lines of code, and it will work on your Hadoop cluster on arbitrarily large data. The other thing is unstructured data. So in an ideal world, you have structured data, which means you have everything cleansed data, put in a CSV, put in Excel, put in a database, so in an easily accessible format. But often, especially if you work for a web company, you have unstructured data lying around in text files. And this is the data that your application servers collect, and then this data gets copied to your Hadoop cluster. This is what you can see here on the second part of the screen. This is an example of log data. Here you can see there is a date, there is a time, so when a certain event occurred, and we have two kinds of event. One is a registration event, and the other is a payment event. For the registration event, we have some other attributes, and for the payment events, we have an email, like who paid, what is the country the user came from, and the amount the user paid. So this is what we will need in the later exercises. Let us just go on. The two basic concepts in Pig. Pig works with two concepts. One is called alias and the other is called a transformation. And what happens when you create a Pig script? So again, you have unstructured data lying around on HDFS or on any kind of big data storage. And then what you want to do is that you read these files and you give a schema to it, so you organize it in a kind of tabular format, which is much easier to work with. So at the first step, you will load these files. And when loading, you define the structure for these files. Defining a structure means telling Pig how it should see such a file. For example, in this example, what we have done here is telling Pig in the background that this file is a simple text file, and the columns of the files, the columns of the rows are delimited by spaces. So as you can see here, here is a space, and then here is a space, and then here is a space. So this is something that we can tell Pig how a file looks like. And what we get here is it's called an alias. So Pig creates an alias for us, which is a structured representation of an unstructured file. So this is something that Pig will know how to handle this file, and we can use this as a starting point for our analysis. Let us move on. So it's still not perfect. So it's still not like an Excel table, because we have different kinds of events in this table. We have both payments and registrations. So let us just move on and filter for payments. This is something that we call a transformation in Pig. So there are aliases, which is a structured representation of an unstructured file, and there are transformations, which takes an alias and transforms it into another alias. Just like, for example, doing a filtering or modifying one of the columns, or grouping data, or doing something like this. In this example, this is the filtering. So what we have here now in the second table is already a pretty clean table. It only has payments. So this is something that you could go and just use also in Excel or a database or whatever. So it's a nice format. Another type of transformation is, for example, only selecting one or more columns. Here we only select one column for this data set. This is again a transformation, and it will create a new alias. And here is the point for Pig. It works with aliases and transformations, and with these aliases and transformation, you build up your data flow. And you create your data flow which will take an unstructured file. It will create an alias, do some transformations, and then at the end, just go and save the results to a file on your storage, just like HDFS or S3 in a cloud. Or you can save, or you can show the file, just put it on the screen. So you will have the result that way. So this is a Pig pipeline. And what Pig does, and what we will not cover here, is that it can be pretty sophisticated. You can have more inputs, you can connect them, join them, you can split inputs, you can reuse aliases, not just in a linear manner, but you can always go back and use another alias that you already defined. So Pig scripts can be pretty sophisticated, but for our educational use case, we just go on and use something pretty simple, which is a linear pipeline. So again, these are the aliases, the structured representation of your unstructured data, and in between, transforming an alias into another alias, this is what we call a transformation. So it's aliases and transformations. And what I want to show you still is how you can go and develop a Pig script and how you can debug a Pig script. This is what we will do. We have the analytical questions: which countries did we receive payments from? So how can we calculate this? What is the data pipeline that will answer this question? First of all, if we want to get this data, we only need the payments data. So we will get rid of the registration data and only keep payment records. This will be our first step. And when we are done with this step, then we will move on and we say, okay, now we have the payment records, but we only need the country codes. So right now we will have an alias at this step with all the payment records, and now we will only select the countries. This is a data transformation, and we put it into a new alias, and the new alias will only contain the countries. Right? This is what we want to see. Okay, and when we are done with this, what you can see is that there are duplicates here, because obviously we can have multiple payments from the same country. So what we will do is that we will move on and remove duplicates. So we only have one row for each country. And this is something that we will want to show on the screen. So let us just jump on to the demo. So if you have your VirtualBox open, then just move on and open a terminal. I will make this somewhat bigger to make sure you can see it well. Okay. And then when you have your terminal open, you just go and step into the training directory, and in the training, in the pig directory, so cd training/pig, and you press enter. And when you are here, just make sure that you have the freshest data on your computer, which you can do by issuing git pull. So git pull. Mine says it's already up to date. So if you have the fresh data already, it will say already up to date. Otherwise, you will have some messages here. But the main thing is that after issuing git pull, you will have the fresh data. So let's see what we have in this directory now. Let's just list this directory. So what you can see here, that we have two directories in training/pig. One is the demo, in which you can find the demo scripts, also the script the pig script that we are going to create just right now. And in the solutions, there are similar scripts, uh, but for slightly different use cases. Okay, and the main point here is that you have a data here, a log data, it's called web.log. So I can just move on and just see how this web.log looks like. So let's just get the first 10 lines of web.log. Okay, so this looks familiar, right? This is exactly what we had in the presentation. And if I check how many lines there are in the web.log, now you see it's only 800 lines, so it's definitely not big data. But for our purpose of checking a pig script is perfect. So let me just move on. So what we will do is we will launch pig. You can do this with the pig-x local command. Pig command means just launch the pig shell, and -x local means I don't want to use a real Hadoop cluster. I just want to work from my own directory on my own computer, and I want pig to emulate as if I was on Hadoop. And this is because we have the pig-x local, we can use this weblog from our own virtual machine file system, not a file from HDFS. So this is a simulation of how it would work on Hadoop. But it's important to know that you will use the very same pig script if you want to analyze data on a Hadoop cluster, like huge data on a Hadoop cluster. So let's just launch pig-x local. Okay. So the main thing here is that even though you might get some info messages, you can easily ignore them. What you want to see here is having a line called grunt. And grunt, this is the interactive command line interface for pig, the interface where you can give commands to pig. This is called grunt. So let us just define our data flow. The whole pig script is about defining your data flow. Okay, so what we are interested in is reading this file. I will define an alias, I will call it log, and then I define how this file should be loaded. So the log should look like that I want to load the web.log. I can simply write web.log. I don't need any absolute path or any slashes here, because I launched pig in this directory in training/pig, and in this directory training/pig there is the web.log file. So pig will know that it should look for the web.log in my current directory, because I run it in local mode, so it will not look for the file on HDFS but on the local directory, and because I ran it from training/pig, it will look for the file in this directory. So okay, so let's say I want to load web.log, and I need to define pig what is the structure of this file, and this goes with the using command. So I will go using pig storage. Pig storage means that think about this file as a normal text file. It could be, instead of pig storage, you could read any kind of structured formatted file, or you can even read from a database, or there are many things. You can even write your own storages. But the main thing here, what we will use in this class, is pig storage. And pig storage is for reading simple files, simple plain text files. And here comes the structuring part, which will be very easy. For pig storage, I will give a parameter. What is the delimiter in the rows? And I say it's space. If you want to express space, usually you will need to put it between apostrophes. So you just say this is a space. I just say this is a text file, and the columns in this text file are delimited by spaces. Okay, so this is how my data looks. And now I define the structure of the data, which goes with the as keyword. before we define the structure of the data, just note that somewhere we have capitals, somewhere we have something that we call camel case, which is every word starts with a capital but lowercase letter later. And yeah, at some point we only have lowercase letters. Pig is case sensitive when it comes to a few things. For example, the pig storage you can only write with big P and big S and lowercase everything else. And all the other things like loading and using is not case sensitive. You can use it big or small, doesn't matter. If you're a professional, here is a guideline for you. Any time that we use class names or function names, it's case sensitive, and it's not case sensitive at other places. Okay, so we use the pig storage, and let's define how this data looks like. So the first part is easy. There is a date and a time. So I say there will be a date, which is a char array. A char array means it's a string. And then comes a time, which is again a string. And then comes an action, which is again a string. And then I will simply continue this line. Then comes, okay, what comes next? In registration, there is this word coming, which is we call a registration source. And by payment, there is an email coming. But because I already know that I'm only interested in payments, and I will filter for payment very, very soon, I will just say, okay, an email will come later. An email is also a char array. All right, and then after the email in a payment, there is a country code and an amount. So the country code comes next. I will call it country, char array, and then an amount, which is an integer. All right. It's important to close all the lines with the semicolon and then press enter. Okay, so let's see what we had here. What you can see here again is info messages from Hadoop, so you can ignore it. And as we learned in Unix, because there is no other output, it just means it succeeded. And we are always free to take a look at the data. So I would say, let us just illustrate this data. This is one of the commands of the two commands for debugging pig that we will learn. So the first is illustrate. Illustrate this alias, log. This is how we called it, log. Illustrate log. What happens when I press enter now at illustrate log? What happened here is that pig went to the file and just took one line out of it and showed me that line, so I can check the structure. So it didn't read the data because maybe you have hundreds of terabytes of data on your HDFS, so it will not read the whole data set. Not when you say load, it will not read the data. It will just remember there will be a file there and this is the structure. And when you say illustrate, it will also not read the data either. It will just go on and take a look in the data and show you one line. So what can we see here? Let me make it somewhat smaller so it has a nicer look. Okay, so this is how it looks. This is one line. You can see that the date is a date. Perfect. Time is the time. Action is registration. Okay, action is registration, and then we are expecting an email because at the payment there was an email. Let me show this to you again. I will just come here and head weblog again. So at the payment there is an email, but at the registration there is a source. But we just agreed that we will filter this dataset for the payments, so it doesn't matter how it maps, how pig maps the columns for registration. Let us see. So we have a log, and let us see only the payment records. So I can say the payment is that I want to filter the log by the action, which is here. I want the action to be payment. That's it. It's a double equal sign. It's important. It's simply the syntax of pig for checking for equality. And then you close the line with a semicolon. Okay, so now if I say illustrate payments and semicolon, let's see what's happening. It takes a peek for the file. All right. Let me make this somewhat bigger again. All right. So what we can see here is that here is the log. And the log can be a registration or a payment. Pig is pretty good in this illustrate comments to give you hints about how your data looks like. Okay, so the log can be a registration or a payment, and you can see here in the log that even though registrations are mapped not correctly because we define all our schema for payments, payments are mapped pretty well. So there is an email here, and there is a country here, and the amount also here. And when we filter for payments, we will get rid of the registration columns and only have the payment column. So this is what we wanted exactly. Okay, so again, using the up buttons, you can go through your history, and you can, if you want to fix something, you can always fix the last alias that you created. So we had the log by loading, and let me go back. We have the payment by filtering the log by payment, and then we did some illustration. Okay, so another command that we can use for debugging is called describe. And describe, it follows with an alias, so I can say describe payments. Describe payments, what it will do for us, it will tell us the schema of the file. So it says, okay, here is a payment, and it looks that it will have a date, a time, an action, an email, and a country and an amount. Just exactly what we defined for log. Because we got the log, let's describe log, is the very same. This is what we defined for log, and then we made some filtering, and then we describe payments, but the payments alias, the schema of the payments alias, is the very same than the schema of the log. Why is that? Because filtering doesn't change the structure of your table, it will only change the contents of your table, but you have the same structure going on. Okay, so we have the payments, and all we need from the payments now is the country. So I can say the country only alias should be for each. So for each row in payment, simply generate the country. For each payment, generate country. Okay. Semicolon, enter. It's important, nothing happened, so it means everything is fine. So let me just describe now the country only alias. So what do we expect here? What we expect here that the schema will be only the country because we dropped everything else. For this alias, from each payment record, we only took the country. Right? This is what's happening. Let's just take a look. Let's do an illustrate country only. Okay, this is what we can see. The beginning is just what we already seen, and you can see that in the search tab, the country only is only the country field from that table. Okay, so far we have the countries. And what we want to do now is to get rid of the duplicates. So I can go and say countries, it's a new alias, it should be a distinct of the country only. All right, let's illustrate this. So what we expect here is that this distinct will get rid of the duplicates in country only. Illustrate countries. Okay, so you can see this here. Pig was intelligent enough to adjust the sampling so it makes sense, so it reads duplicates actually, in the sampling. And you can see that in the country there will be duplicates, but in the country only there will be duplicates, but in the countries there will not be duplicates. Okay, so let us just show what countries we have. And for this, the command is called dump countries. Dump countries. And when I say dump countries, it means I want all the countries. And I want to execute this pipeline to my Hadoop cluster and go through all the data and just get all the countries and take it back to me. Because so far what we have done, we were just defining schemas and defining the data pipelines. For that, we didn't need to read all the data, and we used Illustrate, which was only taking a peek, like a sneak peek, into the data and checking some samples. But when I actually want to show the results on the screen, I will need to read through all the data, which can be terabytes of data on a Hadoop cluster. So when I say dump countries, this is where the MapReduce jobs will go and launch. And because we are in a local environment, this will be emulated now. So let me just say dump countries. It will work pretty hard. Okay, and it finished. So there are a lot of statistics and a lot of information. This is just what Hadoop tells you, but the results are here. Here are the countries that we have. And what you can see here is that the countries are in how do you call that? In parentheses. But this is simply how Pig writes results to the screen. It has its reason, but we will not dive into it. The main thing for you is simply that it will just go and get all the countries and put it on the screen. So this is how you can write a Pig script. And if you want to use, if you want to write back your data to the disk instead of showing it to the screen, there is another function called store. So what I want to do here is say, I want to store these countries into the countries.txt, and I have to tell Pig again, just as by the loading, how to store it using Pig storage. And also because there might be, in this alias, there might be several columns, just as what we have in log and in payments, I have to tell Pig what will be the delimiters between the columns in this in the output file. But right now in this example, we only have one column, so it doesn't really matter. I will just tell space again. So I say, store these countries into a file called countries.txt using Pig storage, semicolon, enter. And the same thing goes on. There are MapReduce jobs running, and you see it says successfully stored 6 records in this file. So I will quit the Pig shell. You can do it by typing quit and then press enter. Now we are out of Pig. We are back in our Linux shell. I will just go and press Ctrl plus L. This is what I will press now to clear the screen. Ctrl plus L, clear the screen, and let's see what we have. ls-l, let's see what we have in this directory. You can see that there is a file called countries.txt. So if I cat this file, it will say, oh, I cannot cat it because it's a directory. And it's a directory because on Hadoop, all the output is a directory, because there are several reducers writing the same content, the same results parallelly. So the files are organized in directories, but we learned about this earlier. So I will just cd into the countries.txt. And let's see what we have here. And you can see that there was one reducer output, part R0000, and there is this 0 byte underscore success file, which means that my MapReduce job ran successfully. So let's see what we have in the part R0000. Yeah, and here are the countries. Okay, so it's pretty simple to start with Pig if you run into such simple use cases. And of course, Pig has many other features, but we will not need this for this class. The main thing for you to remember is the basic concepts. Let us just reiterate. Okay, so here it is. So Pig works best if you have unstructured data, and you need big data to use Pig, because what you could see at the Unix lessons, if you have small data, it's just so much easier to analyze the data with command lines tools. So Pig really pays out if you have big data, which is unstructured. It uses aliases and transformations, which with you define the data pipelines. And when you go and do interactive debugging, you can do it in a grunt shell using the describe and the illustrate commands. Okay, before we finish, there is only one thing I want to show you. If I just go back to the virtual machine and I go back, we see this dot means go back to the parent directory. So jump back right here to Pig. Yeah, I am here into Pig. I will press Ctrl L to clear the screen. Okay. So here I have something called the demo directory. So I will just see what's in the demo directory. And here we have the countries.pig. So let us just get the countries. From the demo directory, the countries.pig. And you see this is exactly what we just wrote. And you can use Pig with the -f option. You can execute a file. So you want to say Pig, I don't want to do interactive stuff. I already have my Pig script ready, and just execute this file. Okay, so let's say I want to do it from the demo. I want the countries.pig, and I want to do work with you locally still, because I don't have a Hadoop cluster right now up and running. So I say I want to execute this Pig script and emulate Hadoop. Okay, enter. Let's see what happens. So what will happen is just exactly what you would expect, that it will act the same as if you typed in everything, these commands in a grunt shell. Okay, so main thing, let me go back. Main thing, you can use the -f option to create to execute a Pig script, not interactively develop a Pig application. All right, so yes, that was it, and let me know if you have any questions.